Hey guys, so in this video we're going to learn about completing the square for a quadratic expression. So let's say that I have the following quadratic equation. I have the equation y is equal to 2x squared minus 12x plus 22. So here I have a parabola that has the following equation, and I want to write this equation or I want to express this quadratic in the completed square form. Now we know that the completed square form for a quadratic expression can be written in the form y is equal to a times x minus h the whole thing squared plus k, where h comma k are the coordinates of the vertex of the parabola and a is the stretch factor. So our objective here is to write this in this completed square form. So in other words, for this particular parabola, or for this particular quadratic expression, I want to find the values of a, h, and k. If I'm able to do that, I can write this quadratic expression in the completed square form. So one way to do that is just by equating these two expressions. So if I have this 2x squared minus 12x plus 22 is equal to a times x minus h the whole thing squared plus k. Again, since we simply want to write this equation in this form, we can simply equate these two and we can find the values of a, h, and k by comparing the coefficients. What do I mean by that? Let's expand the right hand side over here. What we have is a times x squared minus 2hx plus h squared, and then we have k. And if we distribute a, we have ax squared minus 2ahx plus ah squared plus k. Now obviously, since this is an equation or an equality, what we have is the left hand side is equal to the right hand side. Now for the left hand side to be equivalent to the right hand side, the coefficients of x squared have to be the same on both sides, which means over here the coefficient on the left hand side is 2. So on the right hand side, a is the coefficient of x squared. So therefore it means, what that means over here is that a is equal to 2. The coefficients of x also have to be the same on both sides. So on the left hand side, the coefficient of x is negative 12. And on the right hand side, the coefficient of x, is negative 2ah. So we can say that negative 12 is equal to negative 2ah. And we already found a over here. So we have minus 12 is equal to minus 2 times h. So we can say over here that negative 12 is equal to negative 4h. And therefore, we can say that h is equal to 3. So now we found the values of a and we found the value of h. And the last thing that we see here is on the left hand side, the constant term is equal to 22. And the right hand side, the constant term is equal to ah squared plus k. So we can say over here that 22 is equal to ah squared plus k. And we already have the value for a. We know that a is simply 2. And we have the value for h. H is simply 3. So we have 2 times 3 squared plus k. And this is equal to 22. So we can say that k is equal to 22 minus 18, which is equal to 4. So now we found the values of a, h, and k. So if we write this, we can rewrite this expression in the form y is equal to a times x minus h the whole thing squared plus k. So we can say that over here y is equal to a is just 2. So we have 2 times x minus h the whole thing squared. So that's x minus 3 the whole thing squared plus k. So that's plus 4 over here. So what we've done is we've written this quadratic expression in the completed square form. And here we can also say that the coordinates of the vertex, for this parabola are h comma k, and since h is equal to 3 and k is equal to 4, we can say that the coordinates of the vertex over here are 3 comma 4. Let's look at another example here. Let's say that I have the following equation for a parabola. Y is equal to negative x squared minus 4x plus 3. And again, I want to write this expression, this quadratic expression, in the completed square form and find the coordinates of the vertex of this parabola, or the coordinates of the turning point for this parabola. Next, we can equate this quadratic expression to the completed square form. So we can say minus x squared minus 4x plus 3 is equal to a times x minus h the whole thing squared plus k. Again, for this quadratic expression here, we want to find the values of a, h, and k. And if we expand the right hand side here, we have a times x squared minus 2hx plus h squared, and we have plus k, and this can be written as ax squared minus 2ahx plus ah squared plus k. Now again, in the completed square form, the coefficient of x squared is simply a. So in this completed square form, a is simply the coefficient of the x squared term. So we can say over here that a is equal to -1. Next, we can compare the coefficient of the x terms over here. So we can say over here that -4 is equal to -2ah. And over here, since a is equal to -1, we can say that -4 is equal to -2 times -1. So that's 2 times h. So we can say that 2h is equal to -4. And if we divide 2 on both sides, we get h is equal to -2. So now we found the values of a and h. And to get the value of k, we can compare the constant terms on both sides. So here on the left hand side, the constant term is 3. On the right hand side, the constant term is ah squared plus k. In other words, these are the terms that are independent of x. So we can see over here that ah squared plus k is equal to 3. Now a is equal to -1 and h is equal to -2. So we have -1 times -2 squared plus k is equal to 3. And -1 times 4, -2 squared is simply 4. So -1 times 4 is -4 plus k is equal to 3. And if we add 4 on both sides, we get k is equal to 7. So now that we have the values of a, h, and k, we can write this quadratic expression, or we can write the equation of this parabola in the completed square form. We can say over here y is equal to a, which is -1. So that's minus times x minus h, the whole thing squared. So that's x minus -2, the whole thing squared. So that will be x plus 2, the whole thing squared, plus k, which is 7. So here is the completed square form for this quadratic expression. And the coordinates of the vertex of this parabola, are h comma k, giving us the coordinates of the vertex of the turning point as -2, 7.